All right, welcome to Module 2.2.1. In this module, we'll be talking about soil health. And this is going to kind of lead us into soil erosion and how we can minimize the impacts of that water that we talked about in Module 2.1. All right, so soil health, you'll likely hear these combined or used interchangeably between soil health and soil quality. And while they are kind of similar, there are some differences between the two terms. And so for soil health, we talk about this, as the soil to function as a vital living ecosystem. And so for me, this living ecosystem is the key thing, or like the key term that differentiates soil health and soil quality. And so soil health is important because we need a lot of these things in order to kind of maximize our soils and their productivity and the quality of that soil. And so as we move into Module 3, we'll be talking about nutrient cycling in Module 3. And this is kind of the basis of this, right? So I guess maybe when I'm thinking about soil health, you can kind of think about it like human health. There are some correlations between humans and soils and plants, and I can kind of make those. And so one of those is going to be nutrient cycling, water infiltration and availability. Like we need food, we need water, we need bone structure for like our stability and support. And then, it's probably good that we have like different microorganisms inside of our gut, our stomach, that are helping us break down some of these nutrients. And so that's kind of what this soil health is encompassing, in that it's really going to provide us a habitat for this biodiversity that are ultimately going to break down those nutrients. And that if we have enough structure, this physical stability and enough water, then we can get that into the plant. So soil health can't be measured directly. And so again, making this correlation to humans, how would you define someone that's healthy? Like a person that is healthy? What are some of the things that you would use to kind of determine if they were healthy or not? So things like blood pressure or heart rate or maybe cholesterols, your triglycerides. What is your breathing capacity? So things like that are kind of what I kind of correlate to measuring soil health. Now, if you had diabetes and you couldn't breathe very well, then you wouldn't be very healthy. So, when I go to the doctor, I'm like, hey, I want you to run all these tests and all these other things. And they come back and they go, you're healthy. And I go, all right, well, cool. I don't really need to do anything more. However, when I look at myself in the mirror, I would not consider myself healthy. I can look at some of my habits, my eating habits, and I can kind of go, you know what, you could probably be healthier. You probably shouldn't be eating out a lot. You probably shouldn't be drinking sweet tea or sodas or things of that nature. So when we're talking about soil health, there aren't too many things that are measured directly that go checkbox, checkbox, checkbox. This soil is healthy. But we do have some indicators that are going to help us measure some of these physical and chemical and biological properties. And then there are also some dynamic and some inherent soil properties that kind of give us an idea about kind of what we're working with. So when I'm thinking about like the inherent soil properties, like these are the air quote genetics of soil. And so the inherent soil properties are that soil texture. There might be some rocks in there. That is kind of how that soil was formed. Is there a lot of, what's the structure of that soil? And then these dynamic properties are things that like we can change as humans. These are some of the things that we can implement that help, benefit these things that we talked about over here, right? So there are some dynamic properties that we can use to benefit some of these characteristics that we're looking for that help us sustain human and animal life. The great thing about this is that they're easy to measure. They're going to measure the changes in that soil function along these three components of soil health. And so one of the things that is important about that is that they're very sensitive to climate and management. So you might hear terms like climate smart agriculture, and they're really going to be trying to focus on improving soil health, because ultimately soil has the propensity to remove carbon dioxide, or the soil doesn't remove the carbon dioxide. The soil provides nutrients to the plants that remove the carbon dioxide. And when those plants die, the carbon goes back into the soil. And that's kind of module 2.3. And then how we manage our lands. And they know that we're going to have to manage these lands more intensely so that we can get the results that we're looking for, so that we can improve crop production to feed a global population. All right, so when we're talking about total organic carbon, and this is kind of the components that we use for soil health, and I've mentioned these a couple of times, there are three components to this. So we have chemical, this is kind of, the pH is going to be important for just about everything that we do. We have our cations and how that soil organic matter, or our cation exchange capacity, holds on to those cations and anions. And then there's also, as I mentioned previously, for when we're thinking about septic systems, that we can kind of bind some of those contaminants before they get into the groundwater. For our biological, these are going to be our microbes, and we'll talk about this in module 2.3. This is where we get this living component from. And so they also need some of these nutrients that are in the soil in order to perform those metabolic functions, so that they can improve that soil resilience. And then down here, we've talked about mostly up to this point, this physical portion, right? So here's our structure, here's our water retention, and then we want to maintain that water. We want to keep that water inside of the soil before it, evaporates or undergoes evapotranspiration and goes back into the atmosphere. Just to look at some of the other chemical properties and the indicator relationships that we might use in order to determine, if this is going well or not. And so, these might be kind of the things, if you're going to compare this to humans, this might be something that you would see maybe on a medical chart, right? So we would take these soil samples, and we would complete these sections, air quote, sections of the chart, and then we would look at them over time and see if there is an increase or a decrease. And so by increasing these, we can increase the biological and the microbial populations and their growth. And so those microbial or biological populations are like the backbone. They're the important thing of this soil health in general. So if we can create an environment that is conducive for these particular, biological earthworms, some other microbes that are in there, soil enzymes, we can improve the microbial biomass for both carbon and nitrogen. And so that ultimately increases the total organic carbon. And we had that Venn diagram because each one of these is kind of, plays a role in how we get to this total organic carbon. Some of the physical indicators, we're definitely looking at bulk density because if we have high bulk density, then we don't have any water movement into that. Available water holding capacity and how well that water moves into the soil, and then how it moves through the soil. And that's going to lead us, to this retention and transportation of those water and nutrients that water and nutrients is important for the plants, but it's also important for the soil microbes. They require water, they require carbon, they require phosphorus, nitrogen, sulfur, very similar to what plants require. The great thing about this is that if you have soil microbes that are using a very small portion of these, C. Hopkins Cafe managed by my cousin Mogul Nina, they're also like giving back or breaking down more than what they're using. So there's a very positive effect for having these soil microbes there. And then this is going to allow us to, kind of estimate what our yield potential is. And, we can see that over time and measure it. And that's kind of one of the things that researchers are working towards, is to go, these things changed. These things changed. What is the change in yield? Because that's ultimately what we're looking for, right? We're ultimately trying to improve our crop productivity. All right, so we mentioned before about soil properties like inherent and dynamic. And so inherent properties are the things that cannot be made, they cannot be altered. Without doing any, major physical or adding some chemical, I want you to think about humans. Hair color is something that is inherent. Now, we can dye our hair, but the truth is like when you look at the genetics of it, I have brown hair. Now, I have blue eyes. Now, I can get contacts, but the inherent properties of my eyesight is, my eyes are going to be blue. So inherent properties are things that we cannot change, or at least not altered by use and management. We could, if you really think about it, it doesn't make sense, but, we could improve, we could change the soil texture by getting, 10 loads of sand and putting on our field and then plowing, and then tilling that, kind of mixing it in and change the soil texture. Now, that doesn't make any sense, but it's possible. Now, the dynamic things are things that we can manage. And so that's going to be, available water holding capacity. How do we improve soil carbon? We can kind of change the structure by tillage, but we don't really want to do that, because remember that the more cohesive and the more consistent that soil is, the better water movement that we have. And so greater water movement means that's more available water holding capacity. Well, depending on the texture. But we want that water to move into the soil and then be able to move through the soil. So inherent, these are the things that are, quote, inherited, and then dynamic, these are the things that, we can do as land managers to improve some of these qualities. But we can't change the rock fragments that are in, 1 acre of soil, to a depth of, 6 feet in a silty clay loam. All right, so soil productivity. Soil productivity is really going to look directly at how we get these yields. And for me, I really like this term optimum yields, because we can throw the kitchen sink at something. In the agronomy world, there's a corn growing competition, and who can grow the most bushels per acre. And I feel like the yield is some astronomical number, like 500 bushels per acre. I might have to look that up, but it's astronomical. I mean, it's just unrealistic. But they put everything in, right? They're spoon feeding all the nutrients. They're making sure that they get enough water, and it's just unrealistic to do this on a large scale. So what I like to use is optimum yields, meaning that your inputs give you the best output. So in module 3, we're going to talk about the law of diminishing returns. And you can only put so much fertilizer and so much water. The crop is only going to grow so much. And then next we have biological. And then finally, this gets to the economics of it. So what are my inputs? What are my outputs? I am growing these crops how do I put the least amount of money into them and get the most return on investment? That's what I think about when I think about optimum yields. How do I maximize or optimize, return on investment? And so I'll tell students, kind of my thought process with this is, do you want to win at the bank or do you want to win at the diner? Because old men love to sit around and talk about all the stuff that they do. And I got this many bushels, or I got this many round bales, or, I grew this much crop and all this, that, and the other thing. But did you make any money at it? Like, that's great that you can, grow a lot. But how much money did you really make? Because, if you're growing a lot, but you're not making a lot, well, then that's kind of counterproductive. All right, so here we are back to soil health again. I just want to reiterate, this is this vital living system. And so this has those biological elements that are key for ecosystem functions and ecosystem services. So, it's going to help us do a lot of these things, and you'll see this in soil quality as well. But again, I just want to refer back to it's living and it's dynamic. There are some things that we can do that change it both for the good and for the bad. So this isn't just about it being a growing medium, which is just soil. We need to have it healthy and living and dynamic to adapt to these changes in environment. That's really what it is because soil is so resilient that it can adapt to changes, to both chemical changes, to environmental changes, and then still bounce back and still be able to support our other living organisms like animals and humans and microorganisms. All right, so now we're going into soil quality. And if you notice, there's nothing that talks about anything that is living in this definition. So again, those are going to be the two main differences, is that soil health refers to a vital living ecosystem that is dynamic. Soil quality is really kind of focused on soil function. Is it able to perform these functions? Can it maintain and enhance water and air quality and support human health? So is it a good soil or a bad soil? So you might have a bad soil that does not support plant life, or at least that it is some sort of production that is going to improve human health or human consumption, but it might be a good soil for building on. And so it's really just the function of that soil so that it can sustain this productivity. As I mentioned, these are used interchangeably, and the biggest difference is that it's this dynamic living resource. So soil quality kind of related to soil function, and soil health is living and dynamic. Just a few other definitions to kind of go through, so that kind of do this so that you can kind of see the difference between what we're talking about. And if you hear these things, maybe that are used interchangeably, it might not be worth getting into an argument over whether or not we're calling soil health and soil quality. Unless you're a soil scientist, then they'll kind of get a little uppity about that because they like to use the proper terms. They spent plenty of time arguing over the definition of that. But, land quality, soil performance, how does the land produce? And moderate the levels of these different things, specifically fertilizers. So soil performance is going to be things like, cation and anion exchange capacity, water movement, because that's ultimately going to end up getting our nutrients into the plants. And then soil resilience is kind of like how much stress can this soil take, and then it kind of reverts back to, or it can bounce back. So after we have basically beat this thing into submission, we've just grown corn after corn after corn. How long does it take for it to get back to its original condition. All right, so that's going to end module 2.2.1. In the next module, we'll talk about soil erosion, and this soil health is really going to kind of be the underlying component to minimizing soil erosion.